Hello friends, in this video we are going to see the trapezoidal speed time curve. In previous video I have introduced you a typical speed time curve where we have seen different 5 regions: rheostatic acceleration, acceleration, free running, coasting and braking. Now let us see the trapezoidal speed time curve. So here I have drawn the speed time curve for mainline services. So you can see here on x-axis time is taken, on y-axis the speed is taken. So it is approximated to trapezoidal speed time curve. So you can observe here the shape of curve is trapezoidal. So again here it is time and it is speed. Time is in seconds and speed is in kilometer per hour. So the trapezoidal speed time curve is divided into these 3 regions. So you can observe here OAD is one region, then ABED is another, and third is BCE. So this is one triangle, this is one rectangle, and this is another triangle. The area under this curve gives you the total distance traveled by the train. So let us see Vm, which is shown here, the maximum speed attained by train during its run. Then T1 is the time for acceleration, which is in seconds. Then T2 is free running time, which is again in second, and T3 is retardation time in second. Capital T is the total time of run, that is addition of T1, T2 and T3. Then alpha is acceleration in kilometer per hour per second, beta is retardation in kilometer per hour per second, and s is the total distance of run, which is in kilometer. Okay, then you can observe here acceleration is nothing but what? Change in velocity with respect to time. So if we take for acceleration period, then it is alpha, which is equal to Vm upon T1, because from 0 to the velocity, change in velocity is what? 0 to Vm. So initially it is 0 and it is reaching the speed as Vm. So that is why change in velocity will be Vm. And what is the time for it? That is T1. So I can write for T1 Vm upon alpha. Then retardation. Again this is change in velocity during the retardation period, and this is for time for it. It is denoted by beta, which is equal to Vm upon T3. But for retardation the change in velocity is from Vm to again it is coming to rest, so that is 0. So the change in velocity is taken as Vm again. So I can write here T3 is equal to Vm upon beta. What is T2? T2 is nothing but the time for running. So here you can observe this AB portion is for free running period. So we have T1 and T3, but we have to calculate now T2. That is capital T minus T1 plus T3. So for T1 we have written from this Vm upon alpha, and for T3 we have written Vm upon beta. The area under curve gives the total distance travelled. So here you can observe the area under this curve will give you total distance travelled. So this is O, A, B, C. But we have divided into 3. One triangle, one rectangle and one more triangle. So that will be the addition of area under this OAD plus rectangle area ABED and area under the triangle BCE. Now let us calculate for this triangle. So the distance travelled during the acceleration in kilometer from area of triangle AOD. So area of triangle is nothing but half into base into height. So this will be half into base is your T1 and height is Vm. So for time in seconds, so we have written here divided by 3600. So this will be half Vm T1 upon 3600 in kilometers. Then for distance traveled during free running period, that is this rectangle. So area of rectangle is length, height into width. So this is Vm and width is T2. So for T2, this is Vm T2 into 3600. Vm is height and T2 is width. Now remaining one is area under BCE. So this is again half into base into height. So this will be half into T3 into Vm. So what is total distance travelled? S is the addition of the 3. So I have written it as equation of 1 plus 2 plus 3. So you are getting S is equal to half Vm T1 upon 3600 plus Vm into T2 upon 3600 plus half into Vm into T3 upon 3600. So I am calling this as equation number 4. Now putting for T1, T2, T3 in this equation, we get S is equal to, that is total distance travelled by the train, is equal to half Vm into Vm upon alpha into 3600 plus Vm into 1 upon 3600 in bracket T minus Vm upon alpha plus Vm upon beta plus for T3 it is half Vm into Vm upon beta 3600. Then after solving further, we are getting one quadratic equation. Vm square in bracket 1 upon 2 alpha plus 1 upon 2 beta minus Vmt plus 3600s is equal to 0. So here for 1 upon 2 alpha plus 1 upon 2 beta, we are calling it as capital K. So your equation will become, for simplicity, Vm square K minus Vm T plus 3600s is equal to 0. So we have the solution for quadratic equation as T plus or minus under root of T square minus 4K into 3600s upon 2K. So here we have taken the negative sign. If we take the positive sign, then speed is too high, which is not practically possible. So we are taking Vm is equal to T minus under root of T square minus 4K into 3600s upon 2K. So this will help you in order to calculate the maximum speed or the total distance travelled by the train.